Hello, everyone. On behalf of everybody here at Insum, I'm very pleased to welcome you to session 5 in our Insum 2019 fall webinar series. Thank you for taking the time to come and see us. Today's presentation is entitled An Introduction to React in Apex. My name is Mark Ruel from the Insum marketing team, and I'll be your moderator. Our series producer is Marc-André Brasseur. And just to let you know before we start, your mics are muted, and we'll be taking questions in the question panel. So write out your questions as they come to you, but please note that we'll be fielding them at the end of the presentation during question period. Our presenter today is Vincent Morneau. Oracle Ace Vincent Morneau is a front-end lead at Insum, is the front-end lead at Insum, and has been passionate about Oracle Apex since 2010. He blogs about technology and speaks at industry conferences. He's well known in the Apex community, and he is the creator of Apex Nitro, an open source application available on GitHub that streamlines the Apex front-end development process. Vincent is also the originator of Apex CL, the recently launched Insum command line utility that allows you to extract an Apex application, lay it on your file system repository in a clear, logical, and hierarchical way. And Apex CL is really a must for team version control activities, for Apex team version control activities. So please check it out at apexcl.dev. Finally, Vincent is also the co-founder of For All a Beautiful Earth, an app recently featured on Forbes.com and designed to help people concerned about climate change to reduce their environmental footprint by joining forces to a worldwide movement of climate action. So you can learn more about For All a Beautiful Earth at forallabeutifulearth.org. And now let's begin. Vincent, the floor is yours.
Oh, thank you, Mark, for the great introduction. I now feel like I should skip my own introduction as it will not be as good as yours. But anyway, so today we're going to talk about React in Apex. And this topic is something I first talked about at Kscope of last year in 2019, and that I did quite a lot of research over the past year. So I'm happy to finally share with you my findings regarding React in the context of Apex. So again, just a little bit about me. From me, my name is Vincent. I'm the lead front end at Insum. I've been an Apex developer for almost 10 years. I do a lot of open source work mostly nowadays. I do some blogging and speaking, but mostly open source work. So I absolutely love sharing my code and my ideas on GitHub. And this is what I did with Apex Nitro, Material Apex, and some other open source projects. Besides actually coding, which a lot of people think I'm doing all the time, I actually enjoy turning off my computer and my phone for multiple days at a time. So I actually go off the grid and disconnect from this connected world, which I thoroughly enjoy. And I am also very passionate about climate change, which we should really call a climate catastrophe at this point. So if any one of you want to have discussions around climate change, I'm always open and for that. So you can reach me on my blog, at my email and Twitter. A little bit regarding Insum, we do, for those of you who don't know, we do custom development, coaching, training, maintenance of Apex applications. So, and recently in the past 2 years, I would say we really upped our game regarding our commitment to Apex innovation and best practices. So it is true to say that for the past year, I've been 100% dedicated to creating best practices and innovation projects in the context of Apex. So we not only do Apex development, but we also do a lot of innovation. But for the topic of today, you're all here to learn about React. So I will actually I will actually assume that most people in this webinar, it's much easier in a room because I can ask the room, but in this webinar, I will assume that most people have heard of React, but that they don't really know what React really is or what it's for or why you should use it. So we're gonna go through the very basic, and the whole session is oriented towards the basics of React. So to get there, we're gonna have to do a little catch up on JavaScript evolution, some of the latest features of JavaScript, because a lot of it is required to use React code. And then we're gonna dive into some of the basic React features. And then we're gonna take those basic and static React features and making them a little more alive. And then finally, we're gonna integrate that into Apex. So hopefully that should cover all the basics for React. And before I dive in, I just have to make a disclaimer because I have been accused in the past of not doing low code sessions. And I know how Apex loves low code, but I'm not known for low code sessions. And this one will not be a low code session as well. So you've been warned. All right. So as I said, I will assume that people don't know what React really is and only have heard of the name and perhaps its popularity. So we're gonna go through the very basic. So at the very core, what React is basically just a JavaScript library, and that its main purpose is to primarily build user interfaces. User interfaces, which means the visual layer, the UI of your page. And by JavaScript library, that means any JavaScript library. Actually, jQuery is a JavaScript library. So React at the very core is no different than that. So React is the engine through which the components are displayed on a web application. So React renders HTML to the client, and it makes it interactive. So React is something that we could call reactive. And now what does that mean? So when you develop standard JavaScript applications, you define all the HTML and the CSS that consist your UI, and then you attach some JavaScript events to that page to execute some interactivity, to execute an action. In the context of Apex, you can easily do this with dynamic actions. But when you think about it, this whole process separates the visual layer from an app from the functional layer of an app. And what React does is, with a set of rules, it combines those two concepts together to make a component live with its visual aspect and its functional aspect together. So that is what makes React reactive, if we want. And since also the third thing is, since React is really just a JavaScript library, it runs on the browser at runtime. And you know how JavaScript is parsed at runtime. So this is important because it makes the rendering of the code, the rendering of the components, much faster than if it was served from a server, like most Apex components are. So there's a performance aspect to React as well when comes the rendering part. React can often be compared to other frameworks of its kind, and that's a fair comparison. So we often hear of Angular or Vue.js, which are essentially good alternatives to React. But the reason why we're talking about React today is because React has become much more popular than the other two, and we'll have a look at that a little bit later. But also one comparison that's most interesting to me is jQuery. Some people are painting the narrative that React is a replacement for jQuery. And as much as I would like Apex to be a little less dependent of jQuery in the future for performance purposes and the sheer fact that jQuery is old, I, for one, do not think that React is a replacement for jQuery because they simply work so differently. So it's a completely different paradigms, and I'm hoping I'll be able to explain that inside of this session. So regarding the popularity, this is a chart that shows the usage of React in comparison to the other alternatives like Angular and Vue.js. So it's no coincidence that I picked React when I had the choice of any of those frameworks. I knew nothing about them a couple of, 2 years ago. But over the past 3 years, React has completely blown away the market and has surpassed the popularity of Angular and the other ones. So there is enough data to suggest that React will continue to grow in the future. So I think that there's benefit from learning from this framework in case you just want to peek through some React code in the future. Who knows? So for as long as I can remember, Apex has provided ways to customize user interfaces. And I know most of the time you can use universal theme and pick whatever's in there. And that for 95% of the cases, it's okay not to customize universal theme. But in reality, Apex has provided a lot of ways to customize a theme, and that's by creating a theme completely from scratch or using an existing theme that's available online. And in there, you can customize the templates, you can create your own templates, you can create template options, and you can assign all of those blocks, all of those pieces of UI to your regions, your items, and your buttons in Apex. And each one of those pieces, if you look into it, if you drill down to the shared component and look into the templates, what you find is essentially a bunch of HTML code with some substitution string that you inject the content into. So in the context of React, it's basically the same thing. What Apex has for themes, templates, and template options, React has a very similar approach, but they call it components. So we're going to talk a lot about components in this webinar. And what's similar between the two is that they both have a very modular approach. So you've got reusable bits of components of HTML code that you can put in Apex, and that is what makes the consistency across your application. When you use the same template for all your regions or all your items, they look the same and they create a consistency for your UI. And the smaller you build these blocks, the more flexible they are, because you can have components in components in components, and you build the little blocks that you can use everywhere. So before I go too far in the theory of React, I think it's important to throw the simplest example possible, a React Hello World. So I'm sorry in advance, most of these code snippets in this webinar are going to be using the Kscope example because I gave this talk at Kscope, but this is really just an example. So at its most simplistic form, what React code is essentially a JavaScript function that returns HTML. That is it. React is HTML in JavaScript. So what we're doing here is we're creating a function called kscope that returns, and all it does is it returns a div. A div is the HTML tag that we are returning, and the content of this div is a static text, hello kscope attendees. So because kscope returns HTML like this, we can now use the kscope element, the function, as a HTML tag. So it becomes a custom HTML tag that we can use and render on the page. So here we are using the React DOM library, which we're going to see later. And React DOM will generate and render the kscope component and put it into your page at your desired selector. In this case, we're dropping it into the body of the page, sorry. So the result of that is simply that we will have a div in the middle of our page where the body is with the static content of this function. So that was for the simple example. We're gonna advance, we're gonna improve this example later on, but let's talk a little bit about why to use React. So the most important aspect of React is something you'll hear quite often, the state management. And it's a pretty hard concept to understand, especially when you've never done React, but to put it simply, it's how objects or components render and behave on a web app. So it's not just the rendering, not just how they look, but also how they behave. And let's take an analogy outside of the coding world for a second. Let's think of water, okay? What happens when you boil water? It becomes steam. But what's the only thing that changed in between water and steam? It's the temperature. So temperature is the state of the water that changed and it became steam. So if you take that back to the concept of a web application, your web page could look one way when the page loads, but when you start interacting with the web page, it will look different. So that's how the state changed depending on a particular property of the page. And because React is ultimately HTML rendered, another reason to use React is because the HTML is rendered on the client side, on the client machine. So it makes rendering significantly faster as opposed to having the HTML served from the server like Apex does. Because when you want to refresh, let's say a report, instead of asking the server for outputting all the HTML, a good example for this is a card report template. So you query a card report template and the server returns the whole HTML. That is not so much efficient because all you really need from the database is the data, and then you can have the client side manage the rendering. But I'm not being fair to Apex because a lot of other components in Apex, like the grid and like especially the grid, are not rendering HTML. They're doing exactly that. And this is a tricky one because React can sometimes feel like a mountain of code compared to the low-code mentality of Apex. But in the world of JavaScript framework, React is relatively considered low-code because it handles a lot of the rendering automatically. React also has a huge community, so you can find your way around snippets. That's great. And React is also very good at creating single-page applications, but we will not see that today. I haven't found a way, and I don't think it's possible to have Apex render single page applications. Okay, a little bit about the setup that you need to start creating React components. Well, first of all, you need to start using a modern code editor. I personally use VS Code, but any other ones will do. Sublime, Atom, Brackets, there are a ton of them that are really good for parsing React code, which that means they will actually understand the syntax of React and give you tips. And then you have to include libraries into your JavaScript. The 3 libraries to include are, first of all, React, the core library to create and parse React code. And then you have React DOM, which is essentially what will render the components into your DOM, into your document object model, into your page. And then there's Babel, which will transform the React code into browser readable code. And we'll explain a little bit later why that's needed, because React has syntactic sugar over JavaScript, so you kind of, they have their own language basically. And then we're going to talk about a new tool to automate creating React builds with Apex. So a little bit of catch up on JavaScript. So a couple of minutes ago, I mentioned that we needed to write JavaScript in a, the real term is ES6. So it's next generation JavaScript. It's JavaScript that's not yet understand in the browser. So what you need to understand is that the JavaScript language is actually built upon ECMA scripts specifications. ECMA script is actually a set of specifications created to standardize scripting languages like JavaScript and many other scripting languages. But the problem is the ECMA script specs, they move faster than JavaScript can. So that is why we need tools to transpile next generation JavaScript into current generation JavaScript. And also browsers, they have engines to interpret JavaScript. Firefox has a different engine than Chrome, which is why we see those differences sometimes. But all browsers are implementing some version of JavaScript, but to the extent to the extent of the newer features, that's totally up to the browser themselves. So in order to normalize the next generation to have a global support and all browsers can understand the same JavaScript, we use something called a transpiler, which transforms the next generation JavaScript into a format that all browsers understand. And that is called transpiling. I find it a little funny because web development introduced a lot of those terms like transpiling, pre-processing, post-processing, which basically mean all the same thing. You take some code and you convert it to a new code that's compatible. Anyway. So the first JavaScript feature I want to have a refresh on is template literals. And this is something you can actually use in all browsers right now. So template literals are a simpler way to construct strings because it allows you to inject data into the strings directly. So one way to construct a string with data in it is to close the string and then append the variable and then close the string and then reopen another string and complete it. With a string literal, what you can do is do a $sign and open the brackets and put your variable in there, and it will give the same result. So it's a much simpler way of defining strings. The only difference is, instead of having a single quote that opens and closes the strings, you have the back tick. So that means you're using a string literal. Then let's talk a little bit about variable scope. Variable scope is a simple but important concept to understand in the next generation JavaScript. So we're going to look at a few examples. We're all used to use the var type in JavaScript. It's very easy to use, but this variable scope is very weak because it actually has no scope. So in this example, I'm declaring a variable and printing it to the screen. So far, so good, right? But the problem comes when you declare that variable inside of a block, so in a different scope. And when you try to print it outside of the scope, it still works. But semantically, this makes no sense. So it makes a lot of people uncomfortable with the var type. The let type is scope specific. So if we're using the same example as before, but declaring a variable inside of a block and then trying to reference that variable outside of the block, it will not compile. It will say the variable is not defined, which makes more sense. So with the let variable type, you actually have to reference those variables at the same level that they are declared. And the third variable type is a constant. It implements the same scope mechanism as the let keyword, but it also cannot be reassigned. So you can't create your variable and then reassign it. Just like most languages, basically. Then another nice feature is the arrow function. The arrow function is a new way and a simpler way to write functions in JavaScript and return data. So if we take a very simple function example like this one, this function is called double. It takes a single parameter, which is a number, and it multiplies it by 2 and returns the result. So the same thing can be written with a much simpler method, but with the arrow function. So first of all, I would be declaring a constant because functions are essentially constants. And the constant has one parameter, which is number 1, and it returns the value that is right next to the arrow. So those two blocks are actually doing the same thing. Another example is pretty much the same, but with 2 parameters. So by having 2 parameters, you would put them in parentheses, just like you would in a function, and it would function the same way. So I suspect you will see a lot more of arrow functions in the future when you search for snippets online, because it's a very, very popular way and efficient way of creating functions. Now let's talk about imports and exports, which are the ability in JavaScript to structure JavaScript files into modules and make them talk to one another. So the goal of import and export is to have JavaScript modules be imported from one file to another. So let's look at this very simple example. So we're having this file called util.js, which has our sum function from the previous slide. And what we're doing here is we're exporting the sum function from util.js. And then in a separate file in main.js, what we can do is import the sum function from another file. So that makes a very, very efficient way of structuring your files so that at the end of the day, what you produce is one single file, which could be the door to your main JavaScript, and then import all other files. Another feature is the spread operator. The spread operator is fairly new, and it allows to iterate, so basically to loop and expand a JavaScript object or an array. So let's look at a few examples, and because it's much better to look at examples for this. So how we could use the spread operator to expand an object or an array is like this. So basically I have, in this example, I have a string, and this string is just one word, hello. If I try to print this string, but wrapped in the spread operator, it converts this string to an array. So the array has 5 elements, one for each letter of the word. It's also very useful if you want to copy an array. So I'm here declaring 2 arrays, A1 and A2, and A2 is actually a copy of, this is an error, this should be A1 right here. So there's a typo in here, but so A2 is a copy of A1, and then what we're doing is we're adding stuff to the second array only. So that allows us to, when we print the 2 arrays, we have 2 separate values. It looks really stupid like this, but if we take another example that we're actually not using the spread operator, so in this case, A2 is equal to A1, then when we push another element to A2, we still have A1 and A2 being the same array, because A2 is becoming a reference to A1, so you kind of get the concept. So spread operator is the best way of copying an array, is what it means. Another example, which is quite fun, we're declaring 2 arrays right here. So this has 2 elements and this has 4 elements, but inside of the second array, we're injecting the content of array 1. And that makes it a very easy way to merge 2 arrays together. And when we print the result, we very easily see how they work, because they were merged in becoming 1, 2, 3, 4, 5, 6. So if you didn't have the spread operator, actually doing this in JavaScript would involve a lot of looping and a lot of, you know. I think that's the last feature of JavaScript we're going to talk about, and this is about deconstructing. So deconstructing is a new way of declaring a variable, but not the variable type. It's a way of unpacking values from an object or arrays. So always think of unpacking values when you hear the word deconstructing. Basically, this example, I declared an object called profile. And this profile object has 2 properties, a name and a job. So when we use deconstructing, let me take a step back. When we don't use deconstructing, the way to get the value of a property would be like this. So I want to get the job out of this profile. So I would declare a variable called job, and I want to get to the job of the profile. All good, all good. But the new way of doing this with deconstructing is by actually declaring a constant called job that is wrapped around curly braces and that references the profile object. And that gives the same result. And I think I'm going to have to go a little faster, so I'll skip this example, but it also works for arrays. Okay, now let's dive into basic React features. Now that we've seen all the relevant JavaScript code that we need to understand React. So, as we've seen before, I want to remind you that what React is actually a way to create function that returns HTML code. So this is conceptually very similar to Apex templates. They're reusable pieces of HTML that you can reuse across your application, your pages, anywhere. And since you have the ability to create your own HTML, you can also create your own HTML tags, just like we did for the Kscope component earlier. So the Kscope component is not a valid HTML tag. It's something that I created myself. And it's kind of become a meme, but it's true at the same time because the market tends to inject a lot of the application logic into JavaScript, and React is really the embodiment of that mentality. So the code that you write in React is called JSX. It is the language, the syntactic sugar on top of JavaScript. That is called JSX. You can also create JSX files to store that kind of code. So I gotta admit, it's a funny looking syntax. It's neither HTML or JavaScript. It's really a mix of the two together. So for instance, here I'm declaring a constant called element, which is literally an HTML block. No quotes, nothing, just a pure HTML. And JSX also has an easy way to embed variables, just like we saw earlier with template literals. So same example here. Sorry. I'm declaring a variable called name. This variable is Vincent Morneau, and inside of a React component, this element that I'm declaring right here, we can embed the value of any other variable declared in the past. So I can inject hello Vincent Morneau in here. And so let's be honest, most of us are coming from an Oracle database background, so we're super aware of SQL injections. And this is important, but in React, any variable that is embedded, like this example above, is actually automatically parsed by the React engine to avoid injection attacks. So there's a security aspect to React as well. But overall, JSX is really just syntax sugar over the JavaScript base. Even if it looks funny at first, and it still looks funny to me, but you kind of grow into this way of defining both the UI and the function inside of the same language. All right, so we will extend the previous React Hello World example that we looked earlier. And here's the full code it requires. First of all, in a full example, what we want to do is import the React libraries. So we've mentioned that we need the React library, the core of React to create the components, but we also need React DOM, which will inject that code into the web application later on. So we import both of them. Then what we do here is we're creating a class and we give it a name. And this will be the component name for later use. So we are creating a class called app, and we will use the app HTML tag later in our code. So the class extends a React component. So that means it basically comes with the whole React architecture and the power of React. And every React component needs to have a render function. So a render function returns your output, the HTML output code for this particular component. In our case, we're still keeping it simple. It's a div with hello world. It's very static. And then the last part is we actually render that component into the page. So what we are doing here is we're rendering the app component into the app ID into the page, or the selector of your choice. This could have been simpler right here. But it is not very useful. You've got to agree to create static components like we did with the hello world example. So what we want to do is create a little more dynamicity, create more dynamic components in React. So we want to be able to inject content inside of those components. So bear with me for a second. I'll explain what that does. This is a new component that I'm creating. In fact, it is still the app component. So we are using the same app component as we were in the previous slide, but instead of outputting a hard-coded hello world in here, we're outputting alerts. Alert is actually something that exists in Apex. It looks like this right here in the bottom right of my screen. So what we want this alert to look like is to have this regular blue icon and a name for my alert and the content of my alert. So instead of outputting the hello world from the previous slide, what we're doing is we're outputting 3 different alert components. But now, where do these alerts come from? They come from a separate file. They come from a completely new React component. So this React component on the right is the alert component, and it also has a render function which returns HTML code for the alert component to look like this. So it has a div, it has a title, it has a body. So this whole thing right here will eventually make the UI for this component on the bottom right. But now what's happening is from the global, from the wrapper, from the app component right here, we're calling in alerts from the second file. So first of all, you have to understand that we're importing the alert, just like we saw in the previous JavaScript examples. We're importing this file on the right to the file on the left. And because I imported the alert here, I can use the alert in my div down below. And then whatever properties I set for the alert on the left, that will trigger to render the component on the right. So let's look at this. I'm actually declaring an alert which has a name and a job. And those are still hard-coded properties. So this is Smith and it has a job of clerk. So we're passing down properties. And in the alert component on the right, these properties will be substituted in here for the name and in here for the job. If you've ever looked at how an Apex template is built, it is very similar. If you go to shared component, open any template, this is what's happening behind the scenes with substitution strings. So we're actually creating HTML and making places for content to go in. Right, so as I mentioned, all the properties that we're defining here for ename are going to be substituted on the right for ename by using this.props, which is a functionality by React, and then you can specify which property. So we're taking the ename. And same thing for job right here. A special property in React is the children property. So the children property in React is basically the content of a component. Whatever we put inside of the React tag, so instead of having the job the job property as a property, as a special property, I now added this property as the content of the alert. So when you do this, React interprets the content of the component as the children property. So clerk is usable by using the children property on the right. So that's one of the special properties of React. It's actually a reserved property name. So you cannot have a property that's called children. That's reserved for the content of components. But the result is still the same. So the alert still shows this because we're substituting the same way. The HTML has not changed. But again, this is very static. So we're making this component a little more dynamic every time. So we've talked about properties. Now let's talk about component state. Because we finally get to the power of React here. In React, a component state is very similar to a property in which you can reference states from one component to another. But the state is actually created as a separate object above the render function right here. So I'm basically saying for this app, my alert will have this object right here, which has a name and a job, and this is a separate object. And I'm creating the alert by passing the state of ename and the state of job. And this goes to the alert component, and we're still able to substitute the values of the state that I'm passing. Now it looks very similar because I'm passing states or properties. What's the difference? Well, the big difference is that properties cannot change, but states can change, and that's a very big difference. So when when a state change, let's say I edit that object right here and I change the name, when that changes, React will automatically re-render all components that are linked to this state. So you don't have to programmatically re-render your page, change the layout, change the UI. If you change the values of the state here, the component will update themselves automatically. So that's very, very useful. So let's take an example that makes a little bit more sense. So I've dropped the app component in here, and we're just looking at the alert component. It's the same as before. So I'm introducing very little new code here. It's the same alert component. Now, what we want to do is have the same, we're having the same component. It looks like this. But we want to introduce the concept of state change. So to illustrate this, we created a property, a state called selected, which is basically the concept of clicking on this alert box and selecting it. So the requirement for this example is that whenever I click on this alert box, it turns green with a check mark. So at first, when I load the page, this alert box is set to, it is not selected. And depending on if the component is selected or not, we will display a separate class for this particular component. So if it is selected, then we want to inject a new class. If it is not selected, we put nothing. So right now, my component is still blue, which means I have not selected my component. But this is where it gets interesting. So now I'm actually saying, if I click on this particular component, then change the state. So we want to change the state by setting selected equals true. Now remember what I said earlier. Whenever you change this value, so I click on this box, I change the value of selected, it is now true. So the state has changed, and because the state has changed, the component will re-render itself. That's part of the React framework. So as soon as I click on it, my alert will turn green with a check mark because I completely changed the class. So obviously this touches a lot of the CSS abilities, how you can add classes and style sheets. So in React, it's actually quite easy to add CSS to the mix. All you have to do is import a CSS file into your file, and then the whole rules of the CSS files will apply to your particular component.
Sorry to interrupt. Would you permit that we take a couple of questions before we continue? We're at 6 minutes to the hour, so if there are people that do need to leave at 3, then perhaps they should be asking their questions now.
Okay.
Okay, so are there any questions? If you could please submit them in writing in the questions pane, and we will answer them. We'll have Vincent answer them. Time really has flown. Okay, well,
so if you have questions, let me know. I will continue for 5 minutes, which I think will close the loop on most of the features.
Thank you.
Okay. So what we basically need to do to make this component really dynamic in the context of an Apex application is to pull data dynamically. So instead of having hard-coded values in the states or in the properties, what we really want to do is have arrays of data that are being pulled into the Apex, into the React components, and then we can finally loop in our arrays of objects to finally render multiple alerts based on an array of data. So in this particular example, what we're doing is we're looking at the array that is the employee arrays, and we are generating a new alert for all employees. But in the context of Apex, what would be really nice is if we could have the array of employees coming from the database. So one way to do this is to have the array being empty at first, and then pull the data from the database from a REST endpoint. So that actually gets all the employees from the database. And then we are able, from the result of this REST call, change the state of my component. So we're overriding this empty array with the content of the database. And then we can render by looping in all of the employees and rendering the alerts, which makes something a lot more dynamic. And one more thing. Now, obviously, still in the context of Apex, it's not an application. Is not just about rendering stuff to the page. It's also about posting stuff. So in conjunction with React component, what could be used to post data to the database is by using REST post endpoints. So basically, let's say I want to save the form of an employee on my page. What we could have is a button that posts the data, and by posting data, by using the post data function from React, what this does is it sends all the content from the React component state. So it's important to synchronize the React component state to the UI of the Apex page to make sure all the content of the Apex page is also in the state of React. Mark, any questions before I move on?
We've got a few that came in, and the first one would be, can we build complete SPA with Apex and React?
Sorry, I'll leave my slide and then I'll just go a little further. So I haven't found a way to do it very efficiently, so I would advise against it. Now, obviously, basically my answer is no. It's not possible to build single page application efficiently within Apex and React.
All right, next question is, how will we use React with current Apex development interface? I have worked with React Native before. I know it's not the same as React, but they share most of the concepts. My question is, most of the concepts, and I think the question ends there.
Yes, so there are a few ways to do it. I highlight 3 ways in this presentation. The first one being by using CDNs and then bundling the React code directly in Apex. That's not the most efficient way for me because it loads the entire React library, which is quite big. So one other way to do it is by using a build tool. A build tool is basically taking your development on your local system and then uploading to Apex only what's necessary to render your React components. And the final way I could encourage is by looking at one of the Apex Nitro templates. Apex Nitro is basically a build tool made explicitly for Apex. So it synchronizes your local development with the Apex application, and there is a template for React in Apex Nitro.
On a similar question, the question is, can you import a whole React app into Apex?
So the answer is partly yes. So one thing I've done is once you start working in React, you're basically on your way to a whole new world of components. So you know how if you've experimented like importing Bootstrap or other kinds of UI libraries like Material Design, you can basically take those libraries and start using those components. And with React, it's almost the same thing. So when you are used to import React libraries, you can just take those components and build it into your own application by simply taking what you need. So one proof of concept I did for this was an Apex plugin that was generating a little card of to play a music video. And that was something that I actually did not code anything. I imported it from one of the React libraries and decided to render one of the media control card. And by doing so, I did not code any of the HTML, any of the CSS, and it did give me a very nice result in Apex.
Here's also a good question. Is there any example of a public app developed with Apex and React together?
I'm not gonna lie, I haven't seen one. Only proof of concepts on my side, because I think it's important that I get to my final thoughts. Experimenting with React for me was very fun, and I don't think React is going away. It's a very popular technology. It was super fun to play with, but it's very unusual to Apex development. I'd say most of the time it's not worth refactoring any of your Apex projects because of the sheer complexity and how the fundamental paradigms of coding are so different from Apex to React. But it was, the result is so nice that I still encourage to consider using it for some new projects, for small components, like maybe for parts of your pages. It could be a good idea.
Another question that just came in. In your experience, when it comes to performance, since React is being rendered on the client side, is it faster when it comes to loading the data and interacting with it compared to a fully native Apex application?
That is a great question, and what I would say is test it yourself. Go to a React site, a React demo site, and just try playing around and look at how it reacts to you as a user on your mobile, also especially on mobile, but also on desktop. And I personally think it's noticeable, the performance of that technology. But my advice is try it yourself. And I do want to, since we're closing down on the hour, I do want to say all the code that I'm showing in this webinar is available on GitHub. So if you are interested in going back and seeing how it was done and how the final app is built, because you can run it yourself, you can go to this URL and use it.
Can we throw a couple more questions at you, Vincent?
Sure, absolutely.
Okay. Do you recommend to use, I guess it's React, use it to customize an Apex application to be using mainly on mobile devices?
So it's also a very good question. What I would say is think of the page designer in Apex. So it's something you use quite often as a developer, and it has multiple pages, but it also has this main page, which is the page designer, which is highly reactive. It's a very complex page, and this kind of page, which is the core of your application, is a very interesting candidate to migrate to React because it deals with the core of your application. And to answer the question, to build a mobile app on React, I'd say I would probably build hybrid apps. So parts of my application would be React and other parts would be standard regular Apex pages. So a bit of both. If you go completely React, there's no need to stay in Apex.
All right, and there's a couple questions. I think they're mentioning the same things. Is the source code of the Apex plugin you just mentioned available publicly? And can we download the example application with the media card plugin?
Let me see. I think I did include the media card plugin in there. Yes, it's there. It's in the GitHub site.
Excellent. Next question is, can the Apex interactive grid model be the state of a React component?
I would not venture into. I would not venture there. It would be an amazing thing to do in the future. And I seriously hope that the Apex team look at React for the future of the Apex front end, because I don't believe jQuery is going to stay forever. In 5 to 10 years, there's got to be something else. Perhaps it's React, perhaps not, but we're going to have to move to a more modern framework in the future.
All right, maybe one last question here. Do you think that Oracle will move templating system of Apex from DB to the browser by using Oracle Jet?
I would absolutely not be surprised. Yes, I think it's possible, and they should. Using Jet or something else, but they should move to client-side rendering.
We have a question that says, what about Angular? But I'm not sure what that refers to. Oh, using Angular instead of Oracle Jet, for example, in the question that was just asked.
It's really a matter of personal taste at this point. They're all the same. They serve the same purpose. They're different products.
Okay, this is actually really interesting. Templating. I think that's all the questions we have. I can't see any others.
All right. Well, if people want to go directly to me for questions, I'm happy to answer. The best way would be probably Twitter, but anyway is good.
All right. Well, thank you very much, Vincent, for that excellent session. Very interesting, and time absolutely flew. And it was, so then I would like to cordially invite all of you who are still here to our next webinar, which is Practical Dynamic Actions, and it'll be presented by Oracle ace Jorge Rimblas, which will be held Wednesday, November 13th, and that's at 2 p.m. as usual. And we'll be sending out your invitations to register to that event soon. We also hope you'll join us for all the fantastically informative webinars we have lined up for you for the remainder of the year, and our full webinar calendar is online at insum.ca/resources/webinars. So please check it out. And once again, thank you very much, Vincent, for this presentation. And this concludes our presentation for today, and a recording of the session will be made available to you this week, and we will email you the link. On behalf of everyone at Insum, thank you for your time, and we really hope to see you soon. Goodbye.
Thank you.